Hello, welcome to the course PH6B13E Computational Physics. The contents of today's lecture is taken from Core Python Programming by R. Nageshwar Rao. We'll continue to discuss topics from Module 1, Introduction to Python Programming. In the last couple of classes, we learned about input and output statements. Today, let's discuss about another important component of Python, which are operators. Operators are tokens that trigger some computations when applied to variables or constants. They are broadly classified into two: binary operators and unary operators. Binary operators, as the name suggests, require two operands on either side of the operator. For example, if you take the operation of addition, you say x plus y, right? So here you have two operands on either side of the operator plus. Similarly, you have subtraction, multiplication, division, etc. So most of the mathematical operators are binary operators. And you also have unary operators, which requires only one operand to operate upon. For example, negation, like minus x. Here you have only one operand. Similarly, there is logical not. Depending on the functionality, operators are divided into four categories: arithmetic operators, relational operators, logical operators, and finally assignment operator. Let's discuss one by one. First, arithmetic operators. As the name suggests, these are operators which perform some arithmetic operations. There are 7 of them: addition, subtraction, multiplication, division. So these 4 have their usual meaning, mathematical meaning. Always remember the thumb rule: if both the operands are integers, the result will be an integer. If at least one of them is a float, then the result will be a float. So if you say 4 plus 2, since both 4 and 2 are integers, your answer will be 6, which is an integer. If you make 4 a float, since at least one of the operands is a float, your answer will be a float now, 6.0. So this is the only thing you have to remember here. Then you have 2 special types of divisions. First one is floor division. Second one is modulus division. Now floor division, this is the symbol, 2 forward slashes. So this is a special type of division to get the whole number quotient. I can illustrate this with an example. Suppose you take 4.4 floor division 2. So normally when you divide 4.4 with 2, the answer will have a decimal, right? 2.2. Now what will yield you a whole number quotient here? Instead of 4.4, if you have 4, then you get a whole number result. That 4 divided by 2 will be 2, the whole number. So when you take 4.4 and does its floor division with 2, your answer will be 2 here, the whole number quotient. Since 4.4 is a float, your answer is a float. Same if you take 7 floor division 3. Once again, 7 divided by 3 is 2.5. That has a decimal. So when you do floor division, what should be the number here which gives you a whole number result? 6, right? 6 divided by 3 will be 2. So when you do 7 floor division 3, you get the whole number quotient 2 here. Modulus division is a continuation of floor division. So floor division yields you the whole number coefficient, and whatever is the remainder, that will be returned by the modulus division. And the symbol is percentage. So when you say 4.4% 2, so here the whole number quotient is 2. 2 into 2 is 4. Whatever is remaining, 0.4, that will be your result here. Same way, 7 modulus division 3. The whole number quotient was previously 2. 2 into 3 is 6. What is the remainder? 1. So 7 modulus division 3 will give you the remainder 1. Next is negation. Symbol is a minus sign here. This is a unary operator. Suppose you have a number 5, you want to find the negative of that or the opposite of that, you just say minus 5. Then you have exponentiation. Probably this is a new symbol compared to C or C++. This is double star. So when you say 3 double star 2, the meaning is 3 to the power 2, which is 9. Okay, so we have in total 8 arithmetic operators. Moving on to relational operators, these are binary operators to check whether a mathematical condition is true or false. Usually these operators are used in while loops and if blocks to take a decision, right? You know how a if block works, right? You check for a condition. If the condition is true, you execute certain set of instructions. If the condition is false, you execute another set of instructions, right? Same way, while loop also. While loop check for a particular condition. If the condition is true, your iterations will be run. If the condition is false, then the command will come out of the loop, right? So these are used for taking decisions. And the result is Boolean. Boolean means true or false. You don't get a numerical value, you only get a Boolean result here. There are 6 relational operators: less than or equal, greater than or equal, not equal, and equal. And these are the symbols. So let's see one of the examples. Less than, like you check x less than y. So when you write x less than y, you are actually asking the question if x less than y. Or when I write 2 less than 3, I'm actually asking the question if 2 is less than 3. And the result is true, right? In this case, this is true. So based on that, you can execute certain set of instruction. Or when I ask the question, if x is less than y, if the answer is false, then you will be executing another set of instructions. So you are basically testing a condition, and depending on the result, you execute certain instructions. Okay. Then you have logical operators. Just like relational operators, these are also used to check whether one or more mathematical conditions are true or false. Once again, they are also predominantly used in while loops and if blocks to check a particular condition and make a decision. And the result is Booleans, true or false. There are 3 of them: logical or, logical and logical not. The symbols are or, and not. For example, when you say x equal to 2 or y equal to 4, the result is true if at least one of them is okay. So either x equal to 2 or y equal to 4, you get a true result. If both are not valid, then you get a false result. Okay. Similarly in AND, when I say x equal to 2 and y equal to 4, the result is true only if both are valid, only if x equal to 2 and y equal to 4. And logical not, so when you say not y greater than 9, sorry, there is a typo here, this n should be small letter. Let me correct it right away, because as we said, keywords are type sensitive. So when I say not y greater than 9, this is true only if y greater than 9 is false. In other words, this is true only if y is less than 9. And the last one is assignment operator. Basically, it connects data with a variable name, or it assigns a value to a variable name. And the symbol is the equal to symbol. So when I say x equal to 2, remember you may get confused between the relational equal to and this equal to. So even though I am saying x equal to 2, actually I am assigning the value 2 to x. So the value of the variable x stored in the memory location becomes 2. There is a fundamental difference between the assignment operator and the relational equal operator. When you say x equal to 2 and x double equal to 2, these two are fundamentally different. So I can illustrate that with an example. So if I say if x equal to 2, this is the relational equal to, as I said, this check for a particular condition, right? So Python will check whether the value of x stored in the memory location is actually 2. If it is 2, then you have a true result. A certain set of instructions will be executed. If the value of x is not equal to 2, then you get a false result. Based on that, another set of instructions will be executed. So this is a condition check. On the other hand, in the if block, if I type something like if x equal to 2, this is actually meaningless, right? You are not checking for a particular condition. You are simply assigning the value 2 to your variable x, which is always true. The moment you assign a value to x, now onward, this is the value of x, right? So this is always true. There is no question of a false result here. So here you are not checking a particular condition. You are simply assigning a value. So whenever you want to do a condition check inside a while loop or an if block, you have to use the relational operator, which is the double equal to. This is one mistake students make quite often during their initial programming days. So keep note of this difference. Now, when you write a Python program, suppose you are writing a single line of code, and if that code has a number of operators, which operator will be executed first and which will be executed last? There is a definite order. This is known as precedence of operators. Action of operators is based on the rule of precedence. So when you write a code, Python scans a line from left to right, just like how we read a sentence, right? It first executes the first precedence operators one by one. Then it will execute the second precedence operators one by one, so on and so forth. And what is the order of precedence? This is the one. So first parenthesis will be executed, then logical NOT and negation. These two have same precedence. So in a line, whichever comes first from the left, that will be executed first. Then third, exponentiation, then multiplication, division, modulus division, floor division. Once again, these four have same precedence. Whatever comes first from the left, that will be executed first. Fifth, addition, subtraction. 6, less than or equal, greater than or equal. 7, equal, not equal. 8, logical AND. 9, logical OR. And finally, assignment. Let's see one example. So when I make a statement, y plus 2 by 3 plus x exponentiation 4. Okay. So look at this table which has the highest precedence, exponentiation, right? So this operation will be executed first. Then what? Then we have division here, right? So this operation will be executed second. Then we have two summations, both have same precedence. So whatever comes first from the left will be executed first. So this plus will be executed third and this addition will be executed fourth. So how does Python make the calculation here? It first calculates x to the power 4. Then it calculates the value of 2 by 3. Then it adds 2 by 3 to 1. Finally it adds x to the power 4 to y plus 2 by 3. This is how it does the calculation. Now you have an assignment. For this statement, you can find out what is the order of precedence, which operation will be executed first and which will be executed last. One thing I want to point out here, especially when you are writing codes in your exams or in your class notebooks, the division is actually a forward slash, right? Usually when you sometimes when you write in your notebook, you write division like this, right? 2 by 3. But this is not accepted by Python. If you are typing in Python text editor or idle window, you cannot type like this. You can type only like this. So this is the accepted syntax. Even though in the literal sense, when I say 2 by 3 like this or 2 by 3 like this, both are same. But in the context of programming language, these two are completely different operations. So when you are writing in your exams or when you are writing in your notebook, always use a forward slash to indicate a division. Never write like this. Okay. Another component of Python is expressions. These are meaningful combination of operators, constants, and variables. Depending on the nature of operators, there are two types: arithmetic expressions and logical expressions. Arithmetic expression is a combination of arithmetic operators, constants, and variables. Like, for example, y plus 2 by 3 plus x to the power 4. If you give a value to x and y, you get a numerical value here, right? So result is typically a numerical value. On the other hand, in the case of logical expression, you have a combination of logical or relational operators, constants, variables, and sometimes arithmetic expressions too. Here, the result is true or false because you are dealing with logical or relational operators. And these are typically used for condition checks. For example, x less than or equal to y plus 3. So if you use it in a while loop, you are actually testing a condition whether x is less than or equal to y by 3. And the answer is a true or false, right? Similarly, a not equal to b. You can use it for a conditional check. Another important aspect of Python, or one of the most important tools in any programming language, this is a function. Right? Suppose you are writing a Python code, a large Python code consisting of thousands of lines. You can arrange it very logically in terms of small modules, right? When we discussed about the aspect of extensibility of Python, we have explained this factor, right? You can logically arrange them into modules and submodules, and each module is known as a function. Function is a small isolated unit of code with a name which performs a specific task. A function can be called by its name from any part of the main program. The data variables that are passed on to the function are called arguments, and after performing a specific task, function returns the control back to the main program with one or more answers. So you have a main program, you want to perform a specific computation. Either you can write it as a part of your main program, or you can write a function for that. So when you call a function in the main program, what happens? The control will now get shifted from the main program to the function. Now you want to pass on some input data to the function, right? These are known as the arguments. So function performs some computation. At the end of the computation, there will be an answer, and function will pass on the answer back to the main program. And during this process, the controls comes back to the main program from the function. So wherever you want to perform computation or specific task, etc., you can define a function, call the function, and get the job done. So this is known as the functional aspect of any programming language. And Python adopted this functional aspect from the C programming platform. There are two types of function: built-in functions and user-defined functions. First, built-in functions. As the name suggests, these are ready-made functions. These are readily available in the Python programming platform. You can use them directly. A large number of libraries are available for a variety of applications. Each library consists of a number of modules, and each module contains a number of built-in functions. So you have libraries. Inside libraries, there are modules. Inside each module, there are functions. For example, in Python, there is a library known as matplotlib. Inside that, there is a module known as math. Inside math module, there are functions like sine, cosine, tan, etc. One thing you have to remember is, to avail a built-in function, first the compiler has to load the corresponding module or library into the RAM of your computer. For example, suppose I have a variable x equal to 0 and I want to find the value of sine x. So when I say print sine x, you get an error message. What's the reason? Sine is a built-in function, but Python doesn't understand that sine is a built-in function. I need to first make Python aware that Sine is a built-in function and I am going to use the function directly. Now, how do you make Python aware? You need to load the corresponding module onto Python. Once you load the module, now you can import whichever function of your choice. Okay. Now, how do you load a particular module and import the function? This can be done in 4 ways. First, you type from math import sine. So you load the math module and you are going to import the particular function sine. Now you can say print sine x. So if x equal to 0, you will get the result is 0. Second method, from math import star. So moment you say star, all the functions available in the math library will be imported. Now if you want to find the value of sine x, you say print sine x. You don't even have to use the print statement. You just type sine x and hit enter, you get the result, because you know Python can work as a calculator. Right? It's perfectly fine. Or you want to find cos value, say print cos x. So you can use any function here. On the other hand, if you are following the first method, if you want to find the value of cos, once again you have to type from math import cos. Then you say print cos x. Similarly, tan, once again you have to import from math import tan, then you print tan x. Right? So each time you have to import the function. Here at once everything is imported. Third method, you say import math, and every time when you use a function there will be a prefix math here. So you say print math dot sine x, print math dot cos x. If the name of the module is really large, you can use a short name. So for example, you say import math as m. Now you can use this short name prefix, print m dot sine x, print m dot cos x. So these are the 4 methods. Which one is the easiest? I think most of you will find the second method easier, right? Okay. So I also recommend you to use the second method. Here you import all the function at once. So this is more convenient, and in terms of programming, this is a smarter way of coding. Okay. There are also other modules like NumPy, PyPlot, PyLab, etc. NumPy is typically used for large multidimensional arrays, matrices, high-level math functions, etc. And PyPlot, as the name suggests, this is for graphical plotting. And PyLab, this combines some of the numerical modules of NumPy and some of the graphical functions of PyPlot. So PyLab can be used for numerical applications as well as graphical applications. So usually in your programming, you will be using the math module and NumPy extensively. Sometimes as part of your lab experiments, you will also use the PyPlot module. Let's now get familiarized with a few important built-in mathematical functions. First one, ceil x. This returns the smallest integer value greater than or equal to x. For example, if x equal to 12.3, when you say ceil x, it returns the smallest integer value greater than or equal to 12.3, which is 13. Floor x, this is opposite of ceil. It returns the largest integer value less than or equal to x. So when I say floor 12.3, the largest integer less than or equal to 12.3 is 12. Then factorial x, it has the same meaning as the name. When you say factorial 3, this will give you the answer 3 into 2 into 1, which is 6. Then f sum x. If x is a list, this returns the sum of values in the list. And one thing you have to remember is the answer is always a floor. So if you have a list x, which is 1, 2, 3, even though you have 3 integer numbers and their sum is 3 plus 2 plus 1, which is 6, the answer will be a float. So f sum x will give you 6.0. Then trunc. Trunc x, this returns the integer part of float x after truncation. So this is a truncation function. So if x equal to 12.473, it truncates the decimal part and returns you only the integer. So trunc x will be 12 here. So this is not rounding off, it just truncates the entire decimal part. So if you have 12.873, your integer part doesn't get rounded off. So you still get 12 as the result here. Then exps, this is exponential. If you say exp1, you get the value of e, right? Basically e to the power 1, that which is 2.718. Then log 10x, this will give you the logarithm of x to the base 10. Then you have log x comma b. So here if you don't give any value to b, if you use a single argument x, log x, that is your natural logarithm, log to the base e. On the other hand, if you put a number in the place of b, that will give you logarithm of x to the given base b. Then POWXY, this will give you x to the power y. So when you write PO3, 2, the answer is 3 to the power 2, which is 9. Then SQRT, this gives you the square root of a given number, and remember the result is always float. So when you say SQRT4, square root of 4 is 2, but the answer will be a float, which is 2.0. Then you have the trigonometric functions, cos x, sin x, tan x, etc. They have their usual meaning, but one very important thing, students always make mistake here. X is always mentioned in radians. So if you want to find the value of sine 180 degree, you cannot simply type sine 180. You get a completely different answer. You need to first convert 180 degrees into radians. 180 degree corresponds to pi radians. Pi is 3.14. So if you want to get the correct answer, you need to type sine 3.14. When you hit enter, you get the answer 0. Similarly, cos 180. You type cos 3.14, then you get minus 1. So this you have to keep in mind. Then degrees x. This basically converts the angle x from radians to degrees. For example, if you want to see pi radians corresponds to how many degrees, you say degrees 3.14, you get 180. Similarly, radians x, it converts angle x from degrees to radians. So when you say radians 180, you get 3.14. Radians 0, you get 0. 0 degrees, 0 radians. So many a times students make a mistake, they forget to put the s here. They simply say degree x or radian x. That's not correct. This is degrees and radians. So I don't strictly ask you to memorize all these built-in functions, but remember, the more you get familiarized with inbuilt function, the better is it for your programming. Your programs become more and more readable, they become more neat, they become smarter, and in terms of coding, it is faster. So whenever possible, try to use inbuilt function. There are a whole lot of inbuilt function for any application. It saves a lot of time for you, and also remember, this is one aspect which makes Python really superior to other traditional programming languages like C. Okay? So make the best use of it and make really smart codes. That's for today. Thank you.